All right, so right now what I'm going to show you is what you need for your test on Wednesday. Your focus, your study guide is due on Wednesday. You have the choice of an outline or index cards, and those are due on Wednesday. Is everyone clear on that? So you have the choice of either turning in index cards or an outline. Whatever you choose works out.
What are we starting with?
So everyone should be aware of that. And why is my computer not doing exactly what I need it to do? So if you look on your study guide, I'm going to start with that. You need to highlight everything under perceptual constancy. Highlight everything under perceptual constancy, please. And thank you. Sorry, I'm trying to get it to come up. It's not doing it. Also, under perceptual constancy, you need to write. You need to add, and if I'm telling you to add something, does it have a reason? What is going on? It's because I had writing week this morning. It's stressed out. Okay, so with perceptual constancy, you need to write in, this is not related to the perception of distance. Okay, you need to highlight Gestalt principles. And you also need to write in, the whole is more than the sum of its parts, which I added this morning. If I added it this morning, it's definitely worth your time. So you need to add in, the whole is more than the sum of the parts. Okay, next you have the Muller-Lyer illusion. You need everything. So glad some of you got a head start this weekend, because I'm moving fast. You're not going to have time to copy it down, so it's not my fault. I gave it to you in more than enough time. Ames room illusion, you just need the first box. Binocular cues requires 2 eyes to see. Monocular. Now this is a very big deal, which I'm going to spend a lot of time working on today because it's very confusing. Very confusing, and it's all over your test. Top-down processing, you just need the first box. Bottom-up processing, you just need the first box. Oh, for interposition, I did write in today, trees near top, flowers at bottom. So for monocular, during interposition, you need to write trees near top, flowers at bottom. So next to interposition, write trees near top, flowers at bottom. I added that today. Sophie, what's up? Illusion of relative size? Oh, it's a quarter. A quarter next to a jack. It's like a jack. Like, you've never played jacks? The jack looks bigger if it's next to a quarter. Alright. Bottom up processing, you only need the first box. Perception, you need just the first box. Moon illusion, just the first box. Contiguity, I did add the word ventriloquist. Figure ground, only the first box. Reversible figures, I added Necker cube. And then visual cliff. Okay, flipping it to your focus, which I published on Saturday, which I told you I would, and you've had more than enough time. You should have come to class today prepared. I see a lot of you aren't, and that pisses me off. real life. So, all right, Gestalt principles you need highlighted. Binocular cues you need highlighted. You need 3 and 4. And that's it. All right, take out the blank sheet of paper. You're going to fold your paper into thirds. I am not thrilled that I did all that work this weekend and people couldn't even be bothered by it. It pisses me off. It really pisses me off. So, fold it into thirds. Let's go. So, at the top of the page, you're going to write Gestalt principles. This stuff is hard. Do your best. Okay, so the first one is proximity. Okay, so what it looks like because all of these things are visual things, it looks at how we process information. It's all about perception. So proximity, we assume that all of these dots are together and they form a box, correct? We assume all of these ones are together and all of these ones are together. That's called proximity. It is the tendency to perceive objects that are close together as part of the same group. Okay, so a real life example, okay? If a bunch of people wear same color, we assume they did it for a reason, correct? Okay, that's a real life example. Your second one is similarity. It is the tendency to perceive things that look similar as part of the same group. Okay, next you have closure. Okay, it is the tendency to complete the figure that are incomplete. Okay, so what is this? What is this? You're all wrong because they're just a bunch of lines. Okay, but closure, we can see what it is. That's the comparison of the two. Sweet, I don't know if you've noticed, but I am in a class, so it's not really ideal. Put it in the box, sweetie. Okay, continuity. Continuity. Okay. So this example has stages. So example 1. Two. 3. Okay. So do the best you can. There you go. All right, so this is the tendency to perceive things as simple as possible with a continuous pattern. Rather than a complex one. There you go. So, how would you describe this? An X, maybe? Yes? And an X that's separated and an X that's separated more? Is that really what they are? No. They're smaller, segmented, but we break it down and think of it as easiest as possible. Then we have contiguity. Okay? There is no visual example. Okay? Biggest one is ventriloquist. Move the dummy's mouth. While their lips don't move. But still make noise. So it sounds like, how many of you have ever seen Jeff Dunham? Okay. You can't help but watch the damn doll. Can we agree? Because his mouth's moving, all that stuff, and it looks like he's talking. But you know for a fact it's Jeff Dunham. But you don't look at Jeff Dunham when the stupid doll's talking. You look at the damn doll because it's making you feel like he is the one talking. That's it. It is the tendency to perceive two things that happen close together in time as related. Okay, so with your highlighter,
Say under continuity the definition after pattern.
okay, so you need contiguity. Just ask questions specifically on that. The tendency to perceive two things that are close together is happening at the same time. And the ventriloquist part is key. Okay, and there is a question on the test that asks you which of the following is not one of them. There's 5 of them. You have to say which one is not. There you go. All right, so monocular cues. Here we go. Monocular cues. Okay, so these can be seen with one eye. With one eye. Monocular. Mono means one. So one eye. So the first one is linear perspective. Okay, so what that looks like okay, parallel lines converge on one another. Okay, we've all had to do that city landscape kind of thing, correct? Okay, so that's one. Then you have relative size. Okay, if you have a big stick figure, then you have a little stick figure. You assume this one is near, this one is far. Okay, so when an object that a person expects to be a certain size appears to be small, and therefore assumed to be further away. Okay, your next one. So you have 1. This is 2. Now let's go to 3, which is overlap. Okay, so overlap. We assume that the vase is further or closer? Closer, and the picture is farther. Okay, if an object appears to be blocking parts of another object, the one in front is closer.
Let's do.
All right, so the fourth one is called aerial perspective. Okay, so draw some trees. We have a mountain rise up from the background. It's a pretty messed up mountain. It's fine. Okay, then we have some clouds here. So the haziness that surrounds an object that is further away from view, caused by distance, to be perceived as great. So every time you think of it, think of a Bob Ross painting, correct? Hello? Okay, super far. Okay, his mountains are very vague, but he spends a lot of time in the damn trees that are up close. Hello? Yeah, same thing. All right, texture gradient. So your fifth,
Perceived as what?
Bob Ross.
Oh, green?
Great.
Oh, great.
Texture gradient. Okay. No idea what I was trying to. Okay, so the smaller and finer is far away. Your clear is close. So the more details you can see, is it closer or further away? The more details you see, the closer it is. Okay, so the tendency for textured surfaces to appear to be smaller and finer as distance increases. Okay, it's just like when you look under a microscope, correct? Hello? Okay, when you look at a microscope and you see something, you're like, oh my god, there's holes everywhere, correct? But when you look at it far away, it looks like one piece. 6. Now, Ricky, you do know I'm not doing this for my health, right? You got this all down?
Yeah.
Okay. Motion parallax. Okay. So, this is my car. It's pretty good. I'm not gonna lie. Alright, my person inside ruined it. That's fine. Okay, so when you're driving and you're seeing trees along the road, okay, are they coming fast at you or slow at you? Hello? Slow. However, when you look out the side window, are they going fast or slow? Yes. So when you look at, when you're driving into the trees, it's coming at you very slow and predictable. When you look to the left or the right and you look out the window, everything's going by super, super fast. That's motion parallax. So this is super fast. This is slow moving. So the motion of objects. In which close objects appear to move more quickly than objects further away. And then finally, your 7th one is accommodation. Okay. So it doesn't look so creepy when we're looking at it. Alright, so next to your eyes, you have eye muscles that move it around. So these are your eye muscles. Okay? So, the brain's use of information about the changing thickness of the lens of the eye in response to looking at objects that are close or far away. Alright, so test it. I want you to hold this as close as you can and try to read the words, and you can feel your eyes like trying to adjust, and it strains your eye, correct? Hello? Try to read it. Don't let it blur out. Okay, response. It kind of hurts my eyes trying to read it. And if you hold it as far as you possibly can, your eyes have to kind of strain the other way, correct? That's accommodation. Alright, so you also have binocular cues. Binocular cues. These require how many eyes? Because why? 2 eyes. There you go. Requires 2 eyes. What? Yes, it's over there. All right, so your first one is convergence. So this is normal vision. This is when your eyes turn in. So it is the rotation of the two eyes in their sockets to focus on a single object. Resulting in greater convergence for closer objects and lesser convergence for objects far. Okay. Then you have one more and that's it. Okay, what I want you to do, stop what you're doing, we're going to write the next one in a second. So, what I want you to do is every single one of you is going to hold your pen fully extended in front of you. Okay? And then you're going to bring the pen straight towards your nose and you're going to keep your eyes staring at it. It's going to kind of strain your eyes. Don't hurt your eyes, people. Okay, so what you're going to do is you're going to turn next to you. One of the pair of you is going to do this all the way in, and the other person is just going to watch your eyes. Then the other person does it, and the other person's just going to watch your eyes. Do that now, and you're going to see convergence. Do it now. Go.
No. I'm supposed to watch your eyes. Oh, wait.
One of you is bringing the pen to your face. Hi, we have things to do. Let's go.
Ready?
There you go. Convergence. Everyone good? Okay. Your next one is binocular disparity. Okay. Okay, that's a really creepy nose, but it's fine. Okay. Your pupil, which allows light in, is 2 centimeter distance apart. So, they see things differently. Okay? The closer things are, the greater the disparity. Okay, so the difference in the images between the two eyes, which is greater for objects that are close and smaller for distant objects. Okay, stop what you're doing and listen for 2 seconds. Okay, you're going to take your finger, you're going to stare straight ahead, and you're going to See how close it's going to my face? Hello? Yes? Okay. So you're going to stare straight ahead. Do not follow with your eyes. You're going to stare straight ahead. You're going to see it. And then it's going to disappear for a second. And you're going to have two of them for a second. And then they're going to cross through. Keep going back and forth. Hold it as close as your eyes you can. Stare straight. You're going to see how the image gets jumbled.
Oh, like there's two fingers.
There's two fingers at one point, yes? Hello? You should have two fingers at one point. Oh my god, guys, it's not that hard. And it's monocular, not binocular. Or binocular, so we have two. You see you have double? You have double 1 point. That's because both eyes are picking up your finger at the same time instead of one eye dominating it, which is why you have double. That is binocular disparity. The further it is away from you, guess what? There's no binocular disparity, really, because your eye, it's far enough away from your face. The closer it is, the more disparity, which means you have two fingers at one point. There you go. All right, so what you need for your test. Okay, you need to be able to say what are the two binocular cues, which are convergence and binocular disparity. Okay, you need to know that it requires two eyes. And then the biggest one you need to have is your contiguity, which we already got. That one you need the most for. That one keeps coming up. Alright, questions, concerns, comments on any of those? They're a big deal. You need to know them. Gestalt principles, which are these ones right here, these ones will keep coming back up and up and up and over and over and over again. Okay, interposition, which we talked about, which is your aerial. Interposition is also known as aerial. So we're going to highlight that, and or interposition. Aerial or interposition is a big one. You have to know that one. Okay. All right. So, what I do, how much time do I have? Does anyone know? I don't either. Okay. Perfect. So, what I do want to talk about is 6 minutes. Perfect. Let's do a video clip then. Perfect. All right. I'm going to do your, you're going to need this for your test. So this is you should have paper out. You should be able to take a quick note. I'm doing visual clip with you right now. Okay.
This question. Her experiment was depth perception is defined as the ability to perceive spatial relations in 3 dimensions. We experience this in everyday activities such as driving a car, reaching for a book, and even writing. We do this by allowing our sensory tools, especially vision, to process our environment and the things around us. This perception of our environment is then processed by the section of our brain called the parietal lobe. This parietal lobe is located just behind the frontal lobe, near the upper part of the forebrain. The main functions of the parietal lobe include the processing of somatosensory events. This includes touch, temperature, and body position. The parietal lobe also accounts for our overall spatial awareness. We might ask ourselves, is depth perception innate or does it develop over time?
Okay.
One main study conducted in 19...
Okay, what does innate mean? Who can raise your hand and tell me what is innate? Alyssa. Okay, so you're born with the skill intact. Okay? What else is innate to us? When we're born, what are some things babies can do without being taught? Give me one, Ripke.
Cry.
They can cry, yes, fantastic. Yes, they can cry. They can breathe to a degree. What? They can drink milk, absolutely. It's called the rooting reflex. They know immediately how to suck on a nipple. That's something they're born with, absolutely, okay? So when we talk about innate, that means they're born with it. As soon as they come out of the womb, they can do it. Okay, so the big question is depth perception innate? And of course,
1960 by
we
Dr.
know-
Eleanor Gibson and Dr. Richard Walk established a start to answering this question. Her experiment was known as the Visual Cliff Experiment. Here is a video of a modern-day visual cliff experiment to demonstrate the setup.
In this study, babies between 9 and 12 months are brought into the
Okay, so here is the basic format of the experiment. Okay, so you have a box. Okay, we have a small checkerboard pattern, and we have a big checkerboard pattern. Is this close or far?
Or
Does it look like it's closer, or does it look like it's further away? If you're a baby on top, does it look like you're close or far? Jesus, guys, think about it. If you're a baby put on the surface, does it look far away, or does it look pretty close? It looks close, yes. If you're crawling on it, it looks small, looks like you can able to cross. When you come over to here and all of a sudden the checkerboard pattern is way down here, does it look close or does it look far? It looks far. So, what the baby is doing, when we put the baby over here, the baby's going to start crawling. We want to see if the baby will cross from the small checkerboard pattern to the big checkerboard pattern, which will show that it is a visual cliff. Will the baby do it or won't the baby do it? What's going to happen is, of course, there's a pane of glass. We're not going to kill kids. Okay, so there's a pane of glass. There's no danger to the kid. It just looks like there is a depth or a visual cliff.
this study, babies between 9 and 12 months are brought into the lab and placed on a large plexiglass top table. Half of the table has a checkerboard pattern just underneath the surface, but halfway across is a visual cliff, which the baby can tell drops off steeply. The plexiglass top continues, so it's perfectly fine to proceed. But the baby isn't so sure, and this is a big drop for a baby just starting to crawl. She wants to get across to get the toy, but she's cautious and looks to the opposite end of the table where her mother is.
Like, hell no, I ain't crawling across that.
In the original experiment, 36 infants, 6 to 14 months, were placed in the center of the table. They were observed as their mothers stood at both the shallow end and the deep end at 2-minute increments. The mothers tried to coax the baby into crawling towards them. All 36 babies crawled towards their mothers at the shallow end without hesitation. However, nearly all the infants refused to go to their mothers at the deep end, which required them to cross the illusionary vertical drop. The experiment shows that depth perception is partly innate, meaning we are born with it, but the majority of its development happens with experience.
Okay, so what you need to know, which I would add to your study guide, okay? The visual cliff shows us that depth perception is innate, which means we're born with it. However, it is sharpened over time via experiences. Okay? Everyone in this room knows that there's one thing that you constantly trip on a regular basis. Would you agree? Hello? There's like a stair in your house, a stair in someone else's house, a walkway. Every single damn time you trip on it. Most of you, I'd probably say up until last year, you probably always tripped outside my classroom because everyone at Plant High School trips outside my classroom before they sanded it down. Do you remember? That little metal, that little concrete little thing popped up. People would fall all the time. So, because of that experience of you tripping really hardcore outside my door when there was a massive concrete little bump, okay, you knew walking around outside on the patio to be careful, correct? That was what we call experience helps our depth perception. We know what to look for. So babies are born with depth perception, but it is sharpened over time. Okay, just like you and I are better doing some things than
The
others.
baby's depth perception started developing as they learned to crawl.
There you go. All right, how much time do I have? Like 3 minutes? Perfect. Ames room is your next major experiment.
Lights, camera, perception. When you were little and some big kids pushed you around, did you ever fantasize about becoming bigger all of a sudden? Well, I did, and now I can, at the Exploratorium, San Francisco's Science Museum. How did I do it? The easy way, by manipulating your perception.
Isn't that cool?
When you first saw me, I appeared to be normal size, because you couldn't see the rest of the room. But as the lights came up and the camera pulled back, your brain performed a new instantaneous analysis. It now saw me as small. It added up all the visual information it had about my size and the size and shape of the room. And then it added in everything it knew from experience about the usual shape of rooms, that they're rectangular
Here, I'll
and
pick
have
it up
right
tomorrow.
angles.
But I'm not thrilled, in case
So when
you
I walked
can't
over-
detect from the tone of my voice, that I put in so much work into getting you prepared, and most of you showed up unprepared today. Pisses me off. Just want to make sure that's clear. Goodbye.